This is practice problem 5.7. The 2010 U.S. Olympic hockey team had 3 goalies: Ryan Miller, Jonathan Quick, and Tim Thomas. The chart below shows the NHL regular season save percentages for Miller and Thomas for the past 5 seasons. And Quick is not included because he didn't play full seasons in the NHL for all 5 seasons. So here's my chart. For part A, I want to calculate the mean and standard deviation for Miller's save percentages. So first, let's calculate the mean. So that's denoted by x bar, and to find that, we're going to add together all of his save percentages. 90.6 plus 91.8 plus 92.9 plus 91.6 plus 91.6, and divide that by the number of observations, which is 5, because we're looking at 5 seasons here. And if I put that into my calculator, that's going to give me 91.7 is his mean save percentage for those 5 seasons. So that's my mean. Now we're going to calculate the standard deviation. So to do that, first we need to find the deviation for each of these seasons, and that is going to be the save percentage. So 90.6 minus the mean, 91.7. So for this season, that is a negative 1.1. And for the next season, he has a save percentage of 91.8, and we subtract the mean of 91.7, and that gives me 0.1 as that deviation. Next season, he had a save percentage of 92.9 minus 91.7 is equal to 1.2, so that's that deviation. Now the next two are the same. I've got 91.6 minus 91.7, so that's going to be negative 0.1, and then this is the same, so I'm just going to write that in there. So those are my deviations, and now I need to find their squares. So negative 1.1 squared is equal to 1.21. 0.1 squared is equal to 0.01. 1.2 squared is equal to 1.44. And then the next two, I have negative 0.1 squared, which is also going to be 0.01 and 0.01. So I've found the squares of the deviations. Now I'm going to add those all up, and that will give me a total of 2.68. So to find my standard deviation, I'm going to take the square root of the sums of the squares of deviations, which is 2.68, divided by the number of observations minus 1, which is 4. And if I put that into my calculator, that gives me a deviation of 0.82%. So that's my standard deviation. Alright, let's move on to part B. We're going to find the difference between the mean and median of the observations and find the value of 1/4 of the range, and then use those to check our standard deviation calculation from part A. So the first thing I'm going to do is find the median. So to do that, I need to arrange those 5 save percentages in increasing order, and I've done that here. And since there's 5 of them, the median is just going to be the center, so 91.6. And then the difference between the mean and the median, our mean was 91.7 minus 91.6 is equal to 0.1%. Since we're looking at save percentages, Now for the range is my maximum value, which is 92.9, minus my minimum value of 90.6. So my range is 2.3%. And then a quarter of that is 2.3 divided by 4 is equal to 0.575%. So let's use that to check what we found before. So we found our standard deviation S to be 0.82%. And that is larger than the difference between the mean and the median, which it should be. And it's pretty close to a quarter of the range. So that looks good. For part C, Tim Thomas has a mean save percentage of 92.54% and a standard deviation of 0.97%. So we're going to compare these numbers with the ones we calculated for Ryan Miller and see what we can say about these two goalies. So here I've just made a chart that shows the mean and standard deviation for each of the players. So you can see that Tim Thomas has a slightly higher mean, but he also has a higher standard deviation. So what can we say from those things? So that means that over the last 5 seasons, Thomas has a little bit better record, but Miller has been a little more consistent since his standard deviation is smaller.